Hello students, welcome to Educate. In the last class, we have discussed about nucleophilic substitution reaction in haloalkane. Now we will discuss about elimination reaction. So as we know, elimination means something will get eliminated. So here from what will eliminate? So during this reaction, in elimination reaction of haloalkane, there will be elimination of hydrogen and halogen. So elimination reaction in haloalkane will be also called dehydrohalogenation. Dehydrohalogenation means halogen will eliminate and hydrogen will eliminate. So elimination reaction in haloalkane will be type of dehydrohalogenation, and it is a type of beta elimination. Why beta elimination? Because hydrogen eliminates from beta carbon. That's why it will be called beta elimination. What is alpha carbon, beta carbon and gamma carbon? So carbon atom to which the functional group will be bonded, that will be called alpha carbon. The carbon atom to which the functional group will be bonded will be called alpha carbon. Same, the carbon to which the alpha carbon will be bonded, that will be called beta carbon, and the carbon to which the beta carbon will be bonded, that will be called gamma carbon. So that was alpha, beta and gamma carbon. Alpha carbon, the carbon to which the functional group will be bonded. Beta carbon, the carbon to which the alpha carbon will be bonded. And gamma carbon, the carbon to which the beta carbon will be bonded. So here elimination reaction in haloalkane is a type of beta elimination. Is a type of beta elimination because hydrogen removes from beta carbon. So that's why the elimination reaction in haloalkane is a type of beta elimination because hydrogen removes from the beta position. So what happened during the reaction? Here, let's see. Okay, just a proceed also. As for example, let's see about this reaction. What happened? This is a haloalkane in which there will be elimination reaction. Reaction will take place in presence of alcoholic KOH. That means when haloalkane will be treated with alcoholic KOH, then beta elimination reaction will take place. And if the reaction will take place in presence of aqueous KOH, in case of there is difference between is alcoholic KOH and there is aqueous KOH. That means alcoholic KOH means KOH will be dissolved in alcohol and then after reaction will take place. So when the alcohol will be taken as a solvent, then the elimination reaction will take place and the product of elimination reaction here will be alkene, as we will discuss. And you have seen in a nucleophilic substitution reaction that when haloalkane was treated with aqueous KOH, there was formation of alcohol. Because in aqueous KOH, KOH was dissociated into Kle plus and OH minus. Here, the nucleophile OH minus ion was in abundance. So this OH minus was replaced the bromine ion or the halogen ion, halogen from there. So that's why when the haloalkane will be treated with aqueous KOH, there will be formation of alcohol, and when the haloalkane will be treated with alcoholic KOH, there will be formation of alkene. How does that happen? Here this carbon is here alpha carbon, it is alpha carbon. This carbon is beta and this carbon is beta. This carbon is beta and this carbon is also beta. So what happened during elimination reaction? What will be the minor product and what will be the major product? So that's indicated by Seth-Jeffs rule. Seth-Jeffs rule, explain about. That will not ask me in examination what is Seth-Jeffs rule. So that's why I have dropped. So what is here? So during elimination reaction, Seth-Jeffs rule states that during elimination reaction, the hydrogen will be removed from that carbon. The hydrogen will eliminate from that carbon which will contain less number of hydrogen. So here this is the beta carbon, here number of hydrogen is 3 and here the number of hydrogen is 2. So that's why elimination reaction when takes place from this hydrogen. That means when the hydrogen will remove from here, that will be the major product. So one hydrogen of this carbon atom will combine with bromine and will form HBr. So when hydrogen will remove from this carbon and the halogen from this carbon, then the valency of this carbon atom become destabilized and that of this carbon also become destabilized. So to make their valency satisfied, there will be double bond formation between both the carbon atom. So between both the carbon atom, there will be double bond formation here. So here when hydrogen releases, so in this product here, hydrogen has been removed from here, alkene formed after the removal of hydrogen from here. So that will be the major product. You watch out here, 81% is here alkene has been formed. And when hydrogen has been removed from this carbon, because here this product formed by the removal of hydrogen from this carbon, this beta carbon, which contain less number of hydrogen. So double bond formed between these two carbon. So that one, and it is the minor product. Obviously 19% only form the pent 1 in and 81% form pent 2 in. One is that, and you know why, what is on which concept the Seth-Jeffs rule is. Actually, when the double bond will be between the that means inner side, then that compound will be more stable. And here that will when the double bond is at the terminal end, then that will be less stable. So here an electrophile could attack very easily, but there the electrophile will fill the steric hindrance. So this compound is more stable, so that's why that is more major product, and this compound is less stable, that's why it's a minor product. And the Seth-Jeffs, that what will be the product, that means which one will be the major product in case of alkene. So that we predict by Seth-Jeffs rule, which states that during elimination reaction of haloalkane, or not only haloalkane, other places also like alcohol and so on. So during elimination reaction, the hydrogen will eliminate from that beta carbon atom which will contain less number of hydrogen atom. This one, okay. Okay, what is elimination reaction and versus substitution? So you already know elimination means something has been removed out from there. So there is elimination reaction. And in substitution reaction, the nucleophilic substitution. So nucleophile will substitute the halogen. Means halogen will go out from there and the nucleophile will bond. While in elimination reaction, the halogen will go out from there and to maintain the valency, the hydrogen from the beta position will also eliminate, and there will be double bond formation between the alpha carbon and the beta carbon. So that was elimination reaction. And what is substitution reaction? That's you already know. Okay, so that was about elimination reaction. Now let's see elimination reaction here and any reaction left. Now let's see directly reaction with metals. Reaction with metals, that means with metals, what's the form? One is here, first one is here Grignard reagent. What happened? Haloalkane react with Grignard reagent, magnesium here. So what happened during in dry ether, the magnesium will react with haloalkane. So magnesium will come between this carbon and this halogen here. So that is the Grignard reagent, that is alkyl magnesium halide. When haloalkane will be treated with magnesium in presence of dry ether, there will be formation of alkyl magnesium halide, which is called Grignard reagent. Yes, alkyl magnesium halide. That will be called Grignard reagent. Keep in the mind, haloalkane react with magnesium in presence of dry ether. There will be formation of alkyl magnesium halide. That will be called Grignard reagent. And during the reaction, there should not be traces of water. That means ether should be completely dry. That means there should not be traces of water. Okay. Otherwise, other product will form. About that we will discuss later on. What is organometallic compound? First of all, organometallic compound. Here, the students who is also preparing for IIT main as well as the NEET examination, that should watch out this concept very carefully. What is organometallic compound? So organometallic compound is the compound in which the metal atom will be directly bonded to the carbon atom. That means the compound in which the metal atom will be directly bonded to the carbon atom, that will be called organometallic compound. Example is Grignard reagent, in which magnesium is bonded to this carbon. One of the example is tetraethyl lead. Tetraethyl lead means C2H5, this one, and tetra means 4 and lead, this one. That was here, that is called tetraethyl lead. In tetraethyl lead, lead is bonded to the carbon of ethyl group. This one here. That is tetraethyl lead, and it is an example of organometallic compound. Okay, that is the example of organometallic compound. This tetraethyl lead that was using as an anti-knocking reagent in the petroleum, that means in the automobiles. This was added to improve the mileage of the vehicle. Nowadays, that's not its use has been banned, but earlier, particularly during the 90s, this tetraethyl lead were used as a knocking agent in the automobiles. Knocking agent means to improve the mileage. What's there? That's not in your fear in the syllabus. So tetra is organometallic compound. Keep in the mind, organometallic compound, the compound in which a metal atom will be directly bonded to the carbon atom. About this one. Example, you know already, Grignard reagent is what? One point, keep in the mind that during the preparation of organometallic compound, there should not be traces of water. Here, the students who is preparing for 12th board examination, it should keep one in the mind, and the student who is preparing for NEET examination and the main examination, they should watch out this one too much seriously. There is probability of asking this question that during the preparation of Grignard reagent, why there should not be traces of water, and in case of IIT main and the NEET examination, there is high probability of asking the questions in about that, why Grignard reagent, during the preparation of Grignard reagent, there should not be traces of water. So what happened here? That compound form, what happened when water will be taken? So firstly, Grignard reagent will form, and that will again react with water. So when water here will be taken, just like water here, it will dissociate into H plus and OH minus ion of magnesium. Bonding between carbon and magnesium, that is covalent. In Grignard reagent, the bonding between carbon and magnesium is covalent. while the bonding between magnesium and halogen is ionic. So that's firstly you watch out, write that. Okay, so let's see here. When Grignard reagent is here, that's react with, when Grignard reagent will be treated with water, what will happen? Water H plus NOH minus ion. So bonding between carbon and magnesium will dissociate. So during that course, the carbon will have negative charge, magnesium will have positive charge, as magnesium is a positively charged species, while the carbon is negatively charged. Here, when bonding between carbon and magnesium will dissociate, then carbon will acquire the negative charge and the magnesium the positive charge, as carbon is a non-metal and magnesium is a metal. So OH minus ion will bond to this magnesium. So structure will be, here there is already bromine one bonded and OH will be bonded, and hydrogen left, that will bond to this carbon atom. So there will be formation of, in this case, ethane, and in other case alkane, any other alkane. So during the preparation of Grignard reagent, there should not be traces of water, because the Grignard reagent formed during the reaction, will react with water and form alkane as a major product. Okay, so that is very important point. And the students who is preparing for NEET examination and IIT main examination, they should keep this information in his mind, because there is high probability of asking this question. Clear, guys? What is organometallic compound? I hope that's clear for you. In the examination, question may ask, which of the following compound is an organometallic compound? There will be option. Or in the following compound, which compound is not an organometallic compound? And there will be option. So in both the cases, you will have to only know that what's the meaning of organometallic compound. That means the compound in which the metal atom is directly bonded to the carbon atom. That will be called organometallic compound. One of question is that. The second question, that is more important for NEET examination and for IIT main examination, that during the preparation of Grignard reagent, why there should not be traces of water. So you will have to write, okay, so you should know, and there will be reason. One of them will be that. So keep in the mind, the Grignard reagent will react with water and there will be formation of alkene as a major product. So that is here. And in 12th board examination, its importance should also not be denied, because that question may also ask in 12th board examination. This question is not frequently asked in 12th board examination, even though there is probability of asking the question in the upcoming examination, and the chances of asking the questions in the upcoming examination should not be denied. So that is here. That was about this Grignard reagent. Another, let's see. When there is formation of Grignard reagent, that is here, that has been shown here. Now Wood's reaction there is. What is Wood's reaction? So during Wood's reaction, the haloalkane reacts with sodium in presence of dry ether, and there will be formation of alkane. In Wood's reaction, the haloalkane reacts with sodium in presence of dry ether, and there will be formation of alkane. How's that? Let's see. This is the question here. That's the reaction here shown. But I shall tell you in detail, because in the NEET exam, in 12th board examination, question will ask directly. But in the NEET examination and in IIT main examination, questions was so that if you will not have the clear-cut concept, then you could not solve the question. So watch out this one carefully. Here the reaction is in short. I am telling you in detail how to do this one. So let's see. I have this one minimized here. This one is the reaction. Why this one? So that I could write. Suppose reaction is with ethyl chloride. You have reacted with sodium in presence of dry ether. Listen what happened. Sodium releases the electron. So chlorine atom released from there, that will gain that electron. So that becomes Cl there. Cl minus, and there will be alkyl group here. No, here chlorine free radical will be there. Here chlorine free radical, Cl minus and Na plus. This Na plus will combine with this Cl. In the same way, there will be another molecule of this chloroalkane and sodium here. In the same way, there will be formation of this ethyl free radical, the chloride ion and the sodium ion. Why? Because sodium will lose the electron. That lost electron will be gained by the Cl chlorine atom. So chlorine atom will take its own electron and left the electron of carbon. So carbon, there will be at the carbon atom, there will be one unpaired electron, and here will be the lost electron of the sodium will be gained by chlorine and will form chloride ion. So that become Na plus. So now here is ethyl free radical, here is ethyl free radical, in which unpaired electron is at this carbon atom and at this carbon atom. So what happened? This carbon atom and this carbon atom will bond together. So what will happen? So this CH3, CH2, that will be bonded to this CH2 and that will be bonded to this CH3. So what will be the structure here? That means here CH3, CH2, this CH2 will bond to this carbon. So here this carbon, and now this carbon will be bonded to this CH3. So that is here CH3. Okay. In short, you can also say that ethyl here chloride, 2 moles of ethyl chloride will react with 2 moles of sodium. 2 moles of ethyl chloride will react with 2 moles of sodium in presence of dry ether. Might be in a number of books you have seen this, but what the structure is like this, and when you will do like this, you could solve a number of questions which frequently asked in IIT main examination as well as in the NEET examination. Okay, and here concept is not different, both are same, but this is in short, this one is in detail. This one is actually reaction is. Here the short technique is this one. Here I have taught you here in detail what is happening here. In detail there is. Because when you will do like this, then there will be questions about which when you will apply these concepts, then you could solve those questions very easily. So what happened here? This chlorine combined with this sodium with and this chlorine. That means the 2 haloalkane will combine with this sodium. That means the chlorine atom of 2 different haloalkane molecule will combine with 2 moles of sodium, and there will be formation of 2 moles of NaCl. Then the valency of this carbon atom become destabilized, and the valency of this carbon atom become destabilized. So this carbon atom will bond to this carbon, and with this carbon there is CH3. So then after this CH3 will be bonded. So firstly CH3, CH2 here. So here CH3, CH2, this CH2 will be bonded to this CH2. So here CH2, and that will be bonded to this CH3. So here this CH3. So like this you can also do, like this one also you can do. Okay. Then after, let's see another reactions. There was what actually was the question asked in NEET. There was NEET examination was that which of them will be the product there, about that question. Then let's see. Just one question I am teaching you here, which has been asked in NEET examination. Question was, this one. Just think how to do this question. Solution. Only when only one type of haloalkane will be taken, then there will be formation of alkane having even number of carbon atom. As for example, when you will take propane, so when you will take propane, suppose this propane, when you take chloropropane here, you take, when you react with sodium, then what will happen? In presence of dry ether, what happened? This chlorine will combine there. So number of carbon atom here will be 6, 3 and 3. So that means there will be formation of hexane. Directly you can write that there will be formation of hexane. So there will be formation of C6H18. No, C6H14. When you have taken odd number of that means haloalkane, in which number of carbon atom is odd, then there is formation of alkane in which the number of carbon atom is even. Actually, what happened here, when the two odd will be added, there will be formation of even number, and when two even number will be added, then also there will be even number. So, as for example, you take butane also. So, like this chlorobutane, yes, 2 moles of sodium, and when also you take butane, chlorobutane. So what will happen? That will combine 4 carbon here, 4 carbon atom here. That means 8. So number of carbon atom here is C8H18. That will be. So odd number of carbon atom can be, that means alkane, in which the number of carbon atom will be odd. That is possible only when you will have to take two different haloalkane, because odd plus even, that can be odd, but odd plus odd will be always even, and even plus even, that will be also even. So as for example, let's see, you can take this one here done, then after you can take to prepare like here, even number of carbon atom, that cannot be formed in good yield. Odd number of, okay, that will form, it can be formed in good yield. Here this can form in good yield, and this one can also form in good yield. So answer is B. But how that will form or not, let's see here. I am showing you how this product will form or not. If you will take haloalkane having two number of carbon atom is 2, that means chloroethane. And when you take chloropropane, when you will take chloroethane and the chloropropane, then what will happen? So like this one, chloroethane, 2 moles of sodium and chloropropane. So here number of carbon atom 2 and here number of carbon atom 3. So 3 to 5, that will form here. But what happens when you will take chloroethane and chloropropane, then that will form. But not only this one will be the product. What actually will happen, the chloroethane molecules will also react with other chloroethane molecules. There will be chloroethane molecules, so number of chloroethane molecules. So there will be a formation of C4H10 also. So in addition to their formation of C5H12, there will be a formation of C4H10 also. In addition to that, there is 3 carbon atom. So the alkane having 6 number of carbon atom, that means hexane. So C6H14 will also form. So when you will take chloroethane and chloropropane, when you will react chloroethane and chloropropane with sodium, then there will be formation of butane, hexane as well as pentane. Pentane will form. I am not telling that pentane will not form. Pentane will form. But in addition to pentane, there will be formation of butane and hexane also. So pentane will not form in good yield. That's why this is the option. That was 2-3 years earlier. This question was asked in NEET examination. So watch out, you may verify there. Okay. Now let's see. That was about the Wurtz reaction. That's all about the reaction of haloalkane with metals. Now we will discuss about the reactions of haloarene. In haloarene reactions, about that we will have to discuss. So haloarene, I have also informed you in the last class that haloarene showed 3 types of chemical reactions. One is nucleophilic substitution reaction. Second one is electrophilic substitution reaction. Haloarene shows nucleophilic substitution reaction as well as electrophilic substitution reaction both. In addition to that, it also reacts with metals. Okay, so haloarene shows 3 types of chemical reactions. One is nucleophilic substitution reaction. Number 2 will be electrophilic substitution reaction. And number 3 will be reaction with metals. Now let's see nucleophilic substitution reaction. Haloarene also shows nucleophilic substitution reaction as the haloalkane was showing. But in haloarene, the nucleophilic substitution reaction is difficult compared to that of haloalkane. Why? First one reason is here, just goes on the reason also. About the reason we discuss here. That is, first one is resonance effect. What's the effect of a resonance? Resonative structure, how to draw, I think you know. But okay, I am teaching you here how to draw the resonative structure. Watch out carefully. In haloarene, how's there be resonance form? Okay, I am writing something large. There be 3 lone pair of electron. What happen? One lone pair of electron that will come here for double bond formation. So between this carbon and this halogen, there will be double bond formation. But during that course, the valency of this carbon atom become destabilized. So both the electron bonded between this carbon and this carbon, that will come to this carbon here. So at this carbon atom, there will be a lone pair of electron. So between here, this carbon have no any effect, because right now this carbon is doing double bond formation with this carbon atom, and in the next instant there will be double bond formation between this carbon and this chlorine. So this carbon will have no any effect, but this carbon here has taken the 2 electron. The 2 electron came to this carbon atom, of which 1 electron is of this carbon and 1 extra electron this carbon will get. So this carbon will have 1 unit negative charge. So 1 unit negative charge. So here will be 2 electron will come to this carbon. This one. Now both the electron will, then after these 2 electron will come between this carbon and this carbon. That means double bond will form between, then after this electron will come to for the double bond formation between this carbon and this carbon. So this carbon will leave this pi electron. So both the electron will come to this carbon, in which this carbon, 1 electron in this double bonding, there is 1 electron of this carbon and 1 electron of this carbon. So this carbon will get 1 extra electron. So there will be 1 negative charge here. So 2 electron will come for the double bond formation between these 2 carbon and a lone pair of electron here. So structure will be here will be lone pair of electron, here double bond. Now there is lone pair of electron at this carbon atom here. There is a pair of electron here. So this electron will come for the double bond formation here. So here between double bond will form between this carbon and this carbon. But between this carbon and this carbon, so there will be the cleavage of bond. So both the electron will come to this carbon. So here will be lone pair of electron, here double bond. Remaining structure this one. Then after this lone pair of electron will come for the double bond formation between this carbon and this carbon. So this pi electron will come to this chlorine. So next structure will be here the double bond formation, and here double bond converted to single bond, and again the 3 pair of electron will come here. Okay, that is, but first structure and last structure is same, so no need to draw this structure. So what you have seen here, in case of haloarene, there is partial double bond characteristic. There is partial double bond characteristic in CX bond, of which the bond dissociation enthalpy is more. Of which the bond dissociation enthalpy will be more. So it will be difficult to cleave this bond, carbon CX bond, in case of haloarene. One reason is due to the resonance, there will be partial double bond characteristic between carbon and halogen, and hence the bond dissociation enthalpy will be more. As a result, the there will be greater amount of energy required to dissociate the bond. So one reason is that. Second reason here, hybridization of this carbon atom here. In case of haloarene, the hybridization of this carbon atom is sp2. How is sp2? You predict. I have told you how to draw. So here percentage of S characteristic will be 33.3%. Percentage of S characteristic, that will be equal to here 1s and total 3 hybrid orbital into 100. That much percent, that equal to 33.33%. Here in case of haloalkane, percentage of S characteristic will be how much? 1 s orbital and 4 hybrid orbital into 100. That is 25%. So percentage of S characteristic of CX bond is more in case of haloarene. That's why this electron will be tightly bonded with the nucleus. So it will be difficult to dissociate the bond CX bond. It will be difficult to dissociate CX bond in case of haloarene compared to that of haloalkane. If you would like to write, you may write that also, as I am telling. Now third one is, so instability of phenyl carbocation. What happened after the cleavage of carbon halogen bond? After the cleavage of carbon halogen bond, there will be formation of phenyl carbocation, and the stability of phenyl carbocation is less. So this bond when dissociate, there will be positive charge on this phenyl carbocation. This will be unstable. So unstable with the product, difficult with the reaction. So after the dissociation of carbon halogen bond, there will be formation of phenyl carbocation, and in case of haloalkane, after the dissociation of carbon halogen bond, there will be formation of carbocation, in which the phenyl carbocation is less stable compared to alkyl carbocation. So as you know, the stable with the product, easier with the reaction. So the cleavage of CX bond, it will be difficult in case of haloarene compared to that of haloalkane. Second point here, what happened? The haloarene is an electron rich species, because here is pi bond, here pi bond, here pi bond. So haloarene is an electron rich species, and the nucleophile which will approach toward this side, that will be the nucleophile which will approach towards haloarene, that is also negatively charged. So it is also negatively charged. So the nucleophile will experience the repulsive force by the molecule of haloarene, and hence reaction will be difficult. While in case of haloalkane, what happened? There is a partial double bond condition, here partial positive charge on the alpha carbon atom. So nucleophile will experience the attractive force towards the alpha carbon atom. The nucleophile will experience attractive force towards alpha carbon atom in case of haloalkane, while the nucleophile will experience the repulsive force when it will approach towards haloarene. So that is here also. So there is 4 reasons why the nucleophilic substitution reaction in haloarene is difficult. One is that there will be partial, you may write that also. Okay, if you would like, then you write this one also, which I am telling right now. So the cleavage of carbon halogen bond in case of haloarene will be difficult. Number 1 will be due to the resonance, there will be partial double bond characteristic. Number 2 is in case of haloarene, the percentage of S characteristic is more. So the bonded electron, that is CX bonded electron, will be tightly bonded, and hence the bond dissociation enthalpy will be more. Next point, third point is that the nucleophile will experience repulsive force when it will approach towards haloarene, while the nucleophile will experience the attractive force when it will approach towards haloalkane. And last point is, after the cleavage of carbon halogen bond, there will be formation of phenyl carbocation, which is highly unstable, while in case of haloalkane, after the cleavage of carbon halogen bond, there will be formation of alkyl carbocation, in which the carbocation will establish themselves by the plus I effect of alkyl group. As a result, the cleavage, or as a result, the nucleophilic substitution reaction in haloarene is difficult compared to that of haloalkane. Okay guys, here the nucleophilic substitution reaction in haloarene is difficult, but that is not impossible. There will be some nucleophilic substitution reaction also, and the nucleophilic substitution reaction in haloarene will take place in adverse condition compared to that of haloalkane. That means in haloalkane, the nucleophilic substitution reaction was taking place easily, while in case of haloarene, the nucleophilic substitution reaction will take place but under adverse condition. Okay guys, now what's the some nucleophilic substitution reaction there will be in haloarene? About that we will discuss, and we will also discuss about some electrophilic substitution reaction in haloarene and the reaction with metals. In addition to that, we will also discuss about some compounds which have some utility in our day-to-day life, which has some importance in our day-to-day life. About that we will discuss in the next class. For this class, it's all. Thank you, Team Educate.